Alrighty, so you'll remember that we've been looking at graphs, and I just want to sort of get everybody on the same page kind of thing. So let's look at the last one here, and then you're going to get a chance to actually do some sort of hands-on stuff pretty soon. So during a demonstration, an instructor placed a 1 kilogram mass on a horizontal table. It was nearly frictionless. The instructor then applied various horizontal forces to the mass and measured the rate at which the mass gained speed or was accelerated for each force applied. The results of the experiment are shown in the table. We have two variables. We have the force and we have the acceleration. Which one I will pick on? Ray today. Which one, Ray, of those two variables, the acceleration or the force, is the independent? Independent. Why do you say that? I'm not saying, you're just taking a guess? Okay. If I want to, what do you think, Ben? Aurora? Which one is the instructor sort of more control over? The force. The force, right? The force. The force is the independent. That's kind of what, yeah. You're kind of right. Yeah. So the force is the independent, and the acceleration would be the dependent, which would mean that the force you should have had down there. And the acceleration should be there, right? Okay. So now the force goes up to 30, so it's probably going to be 0, 5, 10, 15, 20, 25, 30, right? Is that what you did? And the acceleration also 0, 5, 10, 15, 20, 25, and 30, right? And you likely notice that it's almost straight, it's almost equal, right? Like 5, 4.9 kind of thing, right? So it's like there, and like there, and like there, there, right on, and right there. Which means it's not a curve, it's a line. So I'm going to draw a line of best fit. Oh, now what the heck's going on here? Oh, that last one's in the wrong spot. Should be right there, right? Okay, will you let me do this? Right, that'll work. Casey. Okay, so we got our line of best fit, right? What's the next thing we have to do? Describe in words the relationship. It's a linear relationship, right? It's a linear relationship. Write the equation relating to force and acceleration. How do we write the equation? The first step is to find the slope. I like that point, and we'll guess that point. Does it matter which two I pick? No. I think they're all good because they're all like right on the line, right? So we're going to go m equals, what are the coordinates up here? It's 30 and 29.9, right? This one here. And the coordinates at this point are 10 and 9.8. So my slope is going to be 29.9, and I'm going to subtract 9.8. And here it's going to be 30 minus 10. Right? Which gives me a slope of 29.9 minus 9.8 is going to be 20.1 all over 20, which is practically, it's 1, is it not? The slope is 1. Big surprise. The slope is 1. Is the y-intercept going to be 0? Yeah, it's going right through 0, right? So what's my equation? Y equals 1x. Do I even need the 1 there? Not really, right? But just to show that we've done the slope, we should do that, right? The last question is, what are the units of the slope of the graph? The acceleration is meters per second squared. The force is measured in newtons. And so my slope units, that 1 is measured in meters per second squared per newton, which is a completely made up unit. It doesn't really mean anything. Okay. Now, if I just happen to have my force and acceleration the other way, then I would have had newtons over meters per second squared, and then it would have actually meant something, but I'm not going to get into that too much. So Okay? So out of all this, what do I expect you to be able to do? Plot a graph, find the equation of best fit, and at least tell me what the units are and maybe even what the meaning of the slope is. Okay? All right. Now, the next step today is to learn how to do all of that on a computer. Because, in case you haven't noticed, calendar says 2012. Real scientists don't use graph paper. Okay, so your data should look like this, right? A1 should be time, right? And distance. Sure, thanks. Time and distance, right? And then you're just going to go 1, 2, 3, 4, 5. Oh, what did I do?
You missed 6.
Oh, I missed 6.
Is there any way I can shut this all down one?
If you've messed up and you didn't put time and distance in that first row, then what you do is you click on that first row, which would be that one, and then you go right click and you go insert. And it'll just drop everything down for you. That's what you want, Casey?
Mm-hmm.
Yep.
How do we get the wizard?
The wizard has disappeared. Okay? Microsoft and their infinite wisdom make things better, so I'll have to show you how to do things.
How can I get a wizard?
There's no wizard.
Wait, it's supposed to be a long one. Is it okay if I put distance?
Yes, Kate?
No.
All you gotta do is type the data in for now. Once you've got your data in there to create the graph, this is what you do. Just ignore the instructions that are on there. Those are old. I gotta redo them. Okay? So what I recommend is clicking here in A1 and highlighting both columns, including the time and the distance. Okay? And once you've done that, then you're going to go to Insert, the Insert tab across the top. Okay? You're going to pick the Insert tab across the top, and then you're going to select Scatter Plot. Okay? And then pick the top left one here, which is just the data points. And you get yourself a nice graph, just like that.
Just the data.
Okay, so we've got the graph up there. Now we need to make what we call the trend line. The trend line is Microsoft's version of the line of best fit. So watch carefully, Gage. I'm about to show you how to do the trend line.
I'm watching.
I'm showing you right now.
Just me or?
Just you, actually, yes.
Okay.
Everyone else can watch too, but mainly you. Okay, click on the graph itself, and then I need you to go, I think it's under Layout. Okay, pick the Layout tab, and then you're going to pick this one over here that says Trend Line. And I would recommend you go down here to More Trend Line Options, because we want to make it nice. Okay, so More Trend Line Options, and then you see that screen there. Once you get to this screen here, because we want a line, we're going to pick a linear fit. So make sure that one's highlighted. I think it's the default, am I right?
Yeah.
Okay, so that's the default one here. And then I wish this was a default too, but you want to click on Display Equation on Chart because you actually want to
Display.
see the equation, display the equation. You want to actually see what the equation for the line of best fit is. And when you hit close, there you go. There is your line of best fit. And your equation.
Why is my equation in the graph?
Yeah.
mine
You
is
can
too.
you can move
You can
it.
move it. I moved mine. You might not have seen me do it, but it was over there. You can actually move it. Yeah. Okay. So I think that's way easier than welcome to the 21st century. All right. So what I would like you to do is on the back page of that sheet there, there's just some made-up numbers. Okay. I would recommend you practice a couple just to sort of, get it right. There are answers at the bottom. I did these answers on a graphic calculator probably about 12 years ago. The software that ran that is slightly different than the software that's running this, so you're going to get slightly different values. Okay? Don't expect them to be exactly the same.
So they
Having
just
said
push
that,
new?
one person will still call me over and said, I didn't get the value.
Do you push like new to clear it?
Yep, you can get new. Okay, so do a couple of those, and then we're going to start the lab in about 8-9 minutes, something like that.
If you do like the sheet too.
So now what I'd like to do is move into the lab part of the lesson. It's about a day and a half, so we're going to have one part today, only the second part tomorrow. Okay, so what you need is a group, 2, 3, 4 absolute max. Okay, with this many people, I'm going to say one report per group so that I don't have to mark until Christmas time. Okay, so one report per group. Make sure everybody pulls their weight, kind of thing. You're going to need a ruler. There's some rulers up here. You're going to need a weight set back there. Okay, and I'm going to see if I can find. Can I borrow this one, Katie, just to read the instructions off? Okay, so it says here you need a set of lab masses and a ruler, as I said before. In groups of 2 people, calculate the volume of each mass in a set. Yeah. Can you tell me, can one of you guys just grab one of those those masses there for me? What shape are those back there? They're cylinders, right?
I know.
Yeah, what's the volume of the cylinder formula? Something with pi and r. Put it all together now, because it's important, no order. Pi r squared. That's the area of the circle, but I want to know the volume. Times the height. Very good, sir. You'll also
She just
notice
said that.
You'll also notice that it's right here. Volume of a cylinder is pi r squared h. How are you going to get the radius of this?
Half the diameter.
Half the diameter. Very good. Measure the diameter half. Okay. I'm not going to worry about this little bit that's knocked out here. Okay. Not going to worry about that. Not going to worry about the little hanger for either. Okay. So that's how you're going to figure out the volume. I would encourage you to do it in centimeters, not millimeters, because then you're going to have really big numbers. Okay. How are we going to find the mass of one of these things? Believe it or not, I've had people actually try that, and then I let them know that it says right on it how much it weighs. No, I didn't. You said. I said, how are we going to weigh? How are we going to find in with the corner? You jumped in. Yeah, it says it right on it. Okay, you don't need to actually weigh it. Construct a graph of mass versus volume. So make sure mass is on the left-hand side of the y. Okay. You'll also notice, because this will confuse some of you. In this case, while we determine the volume, and it would be considered to be the dependent variable, to make the slope make sense, we're going to put volume on the independent axis and mass the dependent axis. Okay, so we're going to switch them. It's to make the slope make sense. So don't come and hassle me about that. Label the graph on its axis. Add the trend line to your graph. Be sure to show the equation on your graph. What is the slope of the line referred to? In other words, what does it mean? And then use your equation to find the volume of a 375 ground mass and the mass of a 550 cubic centimeter lab mass. And then there's one bonus question. What is this stuff made out of? Figure out the answer, don't share. That's enough fun, okay? I'm going to leave the instructions for part 2 until tomorrow, because that's enough instructions. So get a group, get a lab mass, grab a ruler, start. Start.
I want to.
You guys.
I want to put some
What do you need up, Martin? What do you grab? Or do it on paper. Yes, you do, because you're doing all your lab report on the computer.
I just logged off.
All of it's done on the computer. One per group, so someone might have it.